Welcome back. It's the last Hess's Law problem, and they are bringing the heat. Look at this thing. 7 reactions. And one of the tricks they sometimes do is they'll give you reactions that you don't actually need. Like, don't assume you always have to use every reaction you're given. But this one, we're going to come darn close. Let's see what they want from us. The reaction we are trying to make is the formation of HBr from its elements. So if we're making HBr, hydrogen bromide, that would come from hydrogen and bromine. Bromine's diatomic. Now, something to notice about these reactions is there are a lot of different states. We have bromine as liquid and as aqueous. We have hydrochloric acid, I think. No, sorry, we have hydrogen chloride gas and we have hydrochloric acid. So we have to be careful about our states here. So I'm going to put, I don't normally do this, but I'm going to put hydrogen, gas, and bromine, that's liquid at room temperature, and HBr is a gas. And another thing we need to do before we get going is make sure this is balanced. This reaction has 2 hydrogens and 2 bromines on the left, so our reaction would make 2 moles of hydrogen bromide. So we get to build this using some combination of these, and I've numbered them so we can keep track of what we're doing. Let's get into it. We need we need a mole of hydrogen, and we need it on the left side. Which of these reactions can give us hydrogen? No, yes, no, 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 no. Cool. We have only one option for getting the hydrogen, that's reaction 2, so we know that's got to be right. We take reaction 2 as is, and that gives us H2 gas plus chlorine gas, arrow, 2 hydrogen chloride gas. Okay, one thing down. Next we want bromine. Oh, another thing I'm going to do, now that we've used reaction 2, I'm just going to cross it off because we don't want to touch that one again. If we do, we'll mess up our hydrogen. So everything else that we do from now on, we want to do without invoking reaction 2 anymore. We need liquid bromine on the left, and that's aqueous, that's no good. No, 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 yes. This is the only reaction that contains liquid bromine, and it's the correct number, and it's on the left side, so perfect. We can just take reaction 6 as is. That gives us bromine liquid, arrow, bromine aqueous. Okay, 2 things down. Next we need 2 HBRs as gas, and we need them on the right. Sorry, forgot my thing. We used reaction 6, don't want to touch that again. Okay, we want HBr and we need it on the right, so no, no, no. Oh, that's aqueous, so that's not it. No, this is the only place we get hydrogen bromide gas. We need to flip this to get it to the right side, and we must double it to get 2 HBRs. So we're doing -2 times reaction 7. -2 times reaction 7. So this flips to the left, and we double it to HBr aqueous. This flips to the right and gets doubled to HBr gas. And how are we doing? We have a hydrogen on the left. This is good. We want to keep this. We have a bromine on the left. That's good. We want to keep that. And we have 2 HBr gas on the right. That we want to keep. All the rest of this stuff is bad, and we have to get rid of it. So, lots of work to do, I guess. We used reaction 7, so that one's out of circulation now. Okay, what next? We have all the stuff we need, so now we're trying to cancel this extra stuff. For example, we have a single chlorine, and it's on the left side. To cancel that, we need to find something that can give us 1 chlorine on the right side. That doesn't have any chlorine. No, no. This is the only reaction that can give us chlorine, sorry. Unfortunately, it's on the left side. We need it on the right side, so we get to flip reaction 1. When we do that, aqueous bromine goes to the left. Potassium chloride goes to the left. 2KCl aqueous. Chlorine gas goes to the right. And KBr aqueous, 2KBr aqueous goes to the right. Okay. So what did we cancel there? These bromine aqueous cancel out, and the chlorine cancels out. That is good. What really hurts about this step is in the process of fixing those two things, we created two new problems. We brought in KCl, which we didn't have before, and KBr, which we didn't have before. So now we're going to have to run those down. This kind of feels like whack-a-mole. But hopefully if we whack enough moles, we will get there. Okay, so we solved the chlorine problem. We have 2HCl gas that has to go. Okay. This reaction has HCl aqueous. That's no good. That won't cancel HCl gas. This one doesn't have HCl. This is the only reaction that can cancel HCl gas. If we want to cancel two of these on the right, we need two of them on the left. So this reaction is good. It's on the proper side, but we're going to have to double it to get two HCl gases on the left. So this is reaction 5. We're going to do 2 times reaction 5. 2HCl gas, arrow, 2HCl aqueous. Now that we've done that, the HCl gases cancel out. Does anything else cancel out? Do we get any freebies that we weren't expecting? Doesn't look like it. Boo. I've now used reaction 5. I don't want to draw from that again. Okay, what else can we clean up? We have 2 HBRs on the left, 2 HBr aqueous on the left, which we do not want. To get rid of them, we need 2 HBRs on the right. Can we find that anyplace? HBr aqueous isn't there. This reaction has HBr aqueous. Bad news, it's on the left side. We need it on the right. Other bad news, we need to double this. So we're doing minus 2 times reaction 4. You tired yet? I am. So we're taking this reaction, flipping it, and doubling it. Flip this to the left, double it. We get 2 KBr aqueous. Flip this to the left, we get 2 HOH liquid. Flip and double, I should say. That's just water. They wrote it HOH, which is okay. Flip this to the right and double it, we get 2 HBr aqueous. And flip this to the right, we get 2 KOH aqueous. Okay, what does that cancel? 2 KBr aqueous, gone. We don't cancel the water. 2 HBr aqueous, that goes, and that goes. And we don't have the KOH, so getting closer, but we're still not there. Well, that used up reaction 4, so we don't have much left to work with. Hopefully reaction 3 can finish this for us. We want to get rid of 2 KCl's. I'm just picking on this because it's the highest of the things that's still left that we want to get rid of. We have 2 unwanted KCl's on the left. To get rid of them, we need 2 KCl's on the right. So if we take reaction 3, this already has KCl on the right, but it's only a single one, so we're going to have to double it. we're going to need 2 times reaction 3. And that gives us 2HCl aqueous plus 2KOH aqueous, arrow, double this, 2KCl aqueous, and double this, 2HOH, liquid. Please let everything cancel now. All right, 2 KCLs, there and there, 2 HCLs, there and there, 2 waters, there and there, 2 KOH, there and there. Everything has canceled except the stuff we wanted, 1 hydrogen, 1 bromine, and 2 HBRs. Now, crunch time. Let's add up all these numbers, and man, if this total doesn't come out right, I might just post an errata afterwards so you don't have to hear me crying online. We took reaction 2 as is, so we take this delta H as is, minus 184.0. We took reaction 6 as is, so we take this as is, negative 4.2. We flipped and doubled reaction 5. So we flip this to plus 77, and then we double it to get positive 154. We flipped reaction 1, so we flip this to plus 96.2. We doubled reaction 5, so we double this and get, wait a minute. Why do these both look like 5s? Oh boy. HCl's, yeah, okay, so this really is reaction 5. Up here, when I thought this was a 5, geez, betrayed by my own writing, that's a 7, I'm sorry. That's a 7 in a circle, so the third reaction down, this, was incorrect. This is minus 2 times reaction 7. So we flip this and double it, we get plus 79.9, and then we double it, and we get 159.8. Yikes. Sorry about that. Okay, now that I don't trust myself, let's check these again. Reaction 2, minus 184, check. Reaction 6, unchanged, minus 4.2, check. 2 times reaction 7, minus 2 times reaction 7, we flip this and double it, we get 159.8, check. Flip reaction 1, 96.2, check. Put a plus on that if you want to. 2 times reaction 5, we have minus 77, we double it, we get minus 154. Minus 2 times reaction 4, so we take this number, flip it to 57.3, double it to 114.6, and double reaction 3, we double this and get, oh, that's odd, those are the same number, but I suppose that can happen. So we double reaction 3 and we get minus 114.6. And then, because we added all these reactions together to get this one, we add all these delta H's together. So minus 184 minus 4.2 plus 159.8 plus 96.2 minus 154. And the 114.6's are just going to cancel, so I'm ignoring them. And I get minus 86.2 kilojoules. Now, there are 2 ways you could write this reaction. One is this way, with 1, 1, and 2 as the coefficients. Another way you could write it is you could divide all this by 2 and say that we're using half a hydrogen plus half a bromine to make a single HBr molecule. If you did this reaction, which has half the stuff in it, you would get half the energy, and so your enthalpy would be minus 43.1 kilojoules. Both of these are valid. Whichever one you give, though, you should include the reaction with it so people can see what numbers you used. And let's be good about our states for one last moment. Liquid, gas. So minus 86.2 if you like the whole number version, or if you don't mind fractions, minus 43.1. Hope that helped. I'm going to go lie down for a bit.